Hello world, I'm Sol Farpel and today we're going to deal with 6 of programming skill study set LeetCode problem, which is move zeros. So let's get started. So the problem statement is as this. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. So what it means, so we are given an array of integer and we have to move all zeros in the end and do it in place, which means modify the same array. So we can't do a new array and fill it with the elements. Yeah, and we have to, of course, keep the relative order of non-zero numbers. So, and just to remind ourselves, in place means don't create a new array as the main result, and we have to keep order. So if we have 1, 3, 12, it must stay the same. So we, even it was, for example, 1, 12, 3, we have to keep this position. So it means that we can't sort this array. So here's given examples, and probably this is it. So, and probably before solving and thinking about some solutions, what I do usually is thinking and asking some questions. And the first question, as always, is what constraints tell us here? So the first constraint means that a num's length is not going to be empty, and it's up to 10,000 possible characters. It means that n square is fine, but we have to still search for an optimized one. And we have values that can be also negative here, but it doesn't matter for us as we only care if a number is 0 or non-zero in this problem, which is easy one. And probably also one question that might appear here, as in the code, for example, in the Python, we have none, we return none. And we can ask why a function return none. As I ask myself, why this works as it is. As LeetCode's function is none because we are given nums and we must change num itself. So we could not, we are not creating a new array. That's why we have to just, as states here, we have to do it in place. And we are not gonna change the array, and we are not gonna modify, we just modify it, but we are not creating a new one, separate. So we are not gonna have a separate output. It means that we will return none. The function will return none. So basically this is it. And before, also one more point, when I, this for me, it's one of the main things before diving into the solutions, is to imagine a real-world case scenario. And in this case, for this problem, we can think of a list of bank transactions for a day. For example, this is the transactions. And if non-zero values, for example, 1, 3, 12, it means real transactions. And zeros means that there is empty slot or something, the cancel entry or anything else. So, and we want to compress this list so the real transactions come first, and then we get pushed to the end all the non-zero transactions. So this is basically it. And yeah, this how we can process it, and this how all the these problems are stuck in our head. So now let's dive into the solutions. For this problem, we have two possible solutions as we can think of, which I call them two pointers and one path swapping. But of course, here we have a follow-up, which says, we have a question, could you minimize the total number of operations done? So we have to keep this in our mind, and in the future or later, we have to think of how we can optimize it. So this is basically it. And the first solution is two pointers. And what this solution is. So we want all non-zero numbers to keep their order, and all zeros go to the end. So what we can do, First, we will walk through the array from left to right, and every time we see a non-zero element, we will have 2 pointers. One pointer that goes through the array itself, and one pointer that will keep the position that we have to fill with non-zero element. So basically, when every time we see the non-zero, we will write it to the free position at the front, and after we're done, the front parts will contain all non-zero elements, and then what we have in the end, we'll just have to fill the remaining with zeros. So that's how our elements, non-zero elements, would be in the front, and all zero elements would be in the end. And how we will do it. So this is the example. Basically, here we have this. It's 0, 1, 0, 12, 3, for example, and we keep first. We can call this pointer as right with 0, where the next non-zero should go. And we walk through each number. We see 0 here. We do nothing. Then when we see 1, we write it at a num's right at the 0 position, which right is 0. So 0 index would be replaced by 1. And we will write this index by 1, and we will have this array in the end. So like from after this iteration, 1, 1, 0, 12, 3. You can see that we're just writing this position with 1, so we are not changing the this element itself for now. Then we go to the next part here, and it's also 0. We skip it. Then we go to 12, and as right, we incremented the right after the first non-zero appearing of non-zero element. Then we just do the same with this, and we write to nums 1 would be 12. So the 1 index will be 12, and this now have 1, 12, 3, 12, 3. Then we fill from the index right as we incremented the right as 3. Now all elements would be here. And what we have to do in the end, we have to fill the remainings with zeros, probably, and this is how it works. And the complexity of this solution would be O(n), the time complexity, as we have to first loop and scan all elements once, and then we just second loop will fill the remaining part, which means it's 2n. But when in the interview we have to say that the time complexity is O(n). 2 is actually the constant, is nothing changed with constants. So, and the space complexity would be 1, so constant time, as we only use a few variables as right, I, and x. So this is the first 2-pointer solution. Next one, we have one path swapping. What it means? Basically, it's almost the same. We have a pointer right, but here, so if we want make sure that we are not, if we want deal with filling the elements that we have in the end with zeros, we just do swapping instead. First, we scan through the array, and when we see a non-zero element, we will swap it with the right, so which is the position at the front, and we will swap these elements. For example, here when nums is 0, we skip it. Then when nums is 1, we will swap this with index 0, and now we will have 0, 1. So we're basically swapping and writing the element in here and here. Here we write the element with non-zero, and here we write the element with 0. Basically, this is how we deal with, so we can eliminate fill zeros. So we are not doing the second pass. So it automatically happens with swaps. And the time complexity would be the same. We scan the list once, and each step does constant work. So it's O(n) for the swap. And space would be O(n). And when does swapping do fewer or more writes? So to pass write then fill approach, we write every non-zero once, then write 0 into the tail, and total writes would be non-zeros plus zeros. For the one-pass swapping approach, we writes happen during swaps, and swap equalizes two positions. So swapping is more elegant and one-pass solution, but two-pass write and fill can be better sometimes when you want to minimize swaps, as swaps actually is more operations, as you have to write the elements twicely, as you're doing when you do swap. You write in the first index 0 index 1, and in the first index you write 0. That's why you have two operations. And this is it. This is the solutions. But the main thing here, we want to minimize the total number of operations done. This is the problem, as one pass swapping is actually seems a better solution sometimes, but actually it does more operations. That's why it's not the case for us, and that's why the solution for me would be two pointers. But what we can do, the problem is, for example, here in this solution, here's, sorry, can we please open the code itself? So this is basically the code for two pointer solution, as we have the we doing write 0 as the one pointer for positions where we have to put the non-zero elements, and we go through the for each element, and if it's not equal to 0, we just write it with x, but and increment the write, and then we fill with zeros. But the problem is here when, for example, we would have such array, for example, 1 2 1 2 3 0 0. When we will go through each of this element, and we will write it with it itself. So for example, 1, it's non-zero, then we go, it's non-zero, we go and we write it with itself. So it's 1, and we will do the operation writing 1 to this position as write 0, and we will do the same. But actually for this array, we don't need to do anything. That's why we would have do something with it, and with it we will have fewer operations. So basically, this is the answer. Let's check it. So yeah, it passed. I'm not gonna submit it because I already did it. And here's the solution. If, for example, here we added checking if the index is the same or not. So if we would have 1 2 3 0 0, we will check, after we check this is non-zero, if the write equal to this index, we're not gonna change nothing, and this helps us to do fewer operations. So this is the solution. Probably this is it for today, and see you. If it was useful, comment down below, and see you tomorrow. Goodbye.